In our last video, we looked at how they were going to dig out the St. Clair Tunnel, and it was with this shield. And we also learned how this shield came about. But using this shield wasn't in the original plan. How they actually ended up building the tunnel was Plan B. Plan A was completely different. They weren't going to use a shield. They weren't even going to make long approaches. They were going to start right on the shore of the river. The reason for this is if it failed, they wouldn't have all that expense of making those long approaches and digging those out. Didn't seem like they had a lot of confidence. In 1886, the chief engineer Hobson recommended to Sir Henry Tyler, the president of the company, that they drive a small horizontal shaft through the center of the eventual location of a full-size tunnel to test the material and to experiment with different methods of working the clay. Hobson planned, at least through 1887, to bore a tunnel 25 feet in outside diameter, which he would line with bricks laid in Portland cement. The St. Clair Tunnel Company hired the firm of William Sawyer Smith and Company to sink the shafts on both river banks down to the level of the proposed tunnel, and then drive an experimental horizontal shaft 8 feet in diameter along the center of the tunnel route. The tunnel company accepted Sawyer Smith's bid, and the work started in December of 1886. The Sarnia shaft reached a depth of 82 feet on the 29th of January 1887, and the Port Huron shaft extended 92 feet vertically by 19th of February. Sawyer Smith then started digging the horizontal tunnels. The Port Huron shaft extended only 33 feet when diggers encountered very soft clay, and Sawyer Smith decided on the 4th of April 1887 to shift all his effort to the Sarnia side. He began the horizontal tunnel from the Sarnia shaft March 7th, and by April 15th this extended 278 feet to the west. The tunnelers encountered a pocket of natural gas on the 15th of April and then serious flooding the following day. Before they could abandon the Sarnia shaft, the workmen installed a wooden bulkhead at the end of the tunnel to prevent the flow of additional natural gas and water into the workings. The shaft filled with water, and Sawyer Smith stopped all work. 2 days later, the flame from the lantern touched off an explosion, producing minor injuries. Work resumed in late June after extensive pumping removed all the water. Then Sawyer Smith abandoned the work on the 19th of July 1887 and allowed the tunnels to fill with water. He lost $5,482 on the work he completed and forfeited a $15,000 performance bond. In late September 1887, the St. Clair Tunnel Company decided to complete the tunnel on its own and to resume work quickly on the project. Hobson made one final effort to excavate the tunnel from shafts sunk close to the riverbank. He intended to construct a shield at the bottom of the shaft and remove the excavated material by hoisting it up the shaft. In April of 1888, Hobson began to sink a new pair of shafts, one on each side of the river. They were roughly 75 feet from the water's edge and had inside diameters of 23 feet. The Canadian shaft extended to a depth of 98 feet, but filled with water and clay as quickly as they could remove the material. Hobson abandoned this strategy by the summer of 1888 and adopted a more radical approach to excavate the tunnel using a shield and to begin the work from 2 large open cuts well back from the river. The open cut on Port Huron side extended 52 feet below grade and was about 200 feet wide and began roughly 1,800 feet from the river. The Sarnia side went back about 2,000 feet from the river. Hobson began work on the open cuts in January of 1889, and tunneling began on the American side on the 11th of July 1889. You can see the freight cars being loaded with the diggings from the excavation, and a lot of this was used to level out the freight yard with the approach. Here's another photograph of the approach closer to the tunnel. And if you ever wonder how you can tell the Sarnia side from the Port Huron side because the entrances are almost identical, look at the pump house. The pump house here you can see on the right. It's got a 4-sided roof, a hip roof, and it has cement blocks for the base. Here's a photograph of it after the tunnel was complete, and you get a pretty good idea. And in this photograph here, you get a little closer look at how the pump house was built out of the material, the stone block. And in this photograph here, right on the right-hand side, you can see the same type of blocks as they used on the tunnel itself. And since we're here, let's take a little closer look at these workers. And in this photo here, taken on the Sarnia side, you can see that the pump house is a two-sided roof, and the walls are actually made of brick. You can't tell it so much from this photograph here, but in this one you can. A landslide at the Sarnia cut delayed the start of tunneling there until the 24th of September. Hobson was the first engineer to combine three innovative methods in constructing a tunnel: a tunneling shield driven by hydraulic rams, a cast iron tunnel lining, and the use of compressed air to protect the workings from an influx of quicksand and water. Hobson did not invent any of these techniques, but combined them effectively for the first time in an extremely difficult and ambitious project. This photograph here is taken on the Sarnia side, and you can see they're using a lot of horsepower. Whether it be on the Canadian side or the American side, it was quite an incline to get down to where the tracks would eventually be. They dug out a lot, and you can see the sides there and how deep they are. Well, they had to get that shield down from the top all the way down to the bottom where the tracks would be. And this is how they did it. In this rare photograph here, we can see the shield being rolled down. And if you look at the bottom there, that rectangle pit, that was called a start pit. And that's where the shield would eventually end up. And that would be at the heading of the tunnel, where the tunnel entrance would be, or where they would start the digging with the shield. Now, if you look at that ramp and look at the top of this shield, you can see it looks like three cables that go around that shield. I mean, something's got to hold this thing in place, otherwise, pow, it gets to the bottom and go right up the other side. So, if you look at the cables, they almost look like they're going to these three guys sitting at the top of the hill. Now, it'd be pretty amazing if those three guys were holding that shield. Well, let's see, an 80-ton shield, that means each one of these guys is holding over 26 ton by himself. And I don't think they were, but it certainly appears that way. So it was good for a smile. I would imagine there was some type of a winch out of sight of the photograph. And in this sketch here, you can see that the shield is already in the pit, right up to the heading, and it's ready to go. In this cutaway version of the shield, you can see the workers digging out the clay. If you look down the bottom there, only 2 or 3 men of the crew of 22 diggers in the shield removed the clay from the shield proper. Another 4 men loaded the clay into cars that shifts of horses pulled along a light rail line to the tunnel portal. I said horses, and that's what they used at first, but the horses didn't do well in the tunnels. They started to bleed from their eyes and their ears and their mouth, which sounded like the bends. They didn't do well in the compressed air, but it didn't seem like the mules had any problem with it. So that's what they ended up using. And the mules brought the cars out of the tunnel. There, a pair of derricks picked up the car bodies and moved them from the bottom of the open cut to the top of the embankment, and dumped the load onto a flat car to be hauled away to a dumping site. The inside of the tunnel had a cast iron liner, which was quite unique. As the hydraulic jacks pushed the shield ahead, say 20 inches, then the men would come in behind that shield that was just being cleared out and start putting up the liner. When all the segments were placed, they would have 13 segments. And once those 13 segments were completed, it was considered one ring. When the tunnel was completely finished, they would have 3,852 connected rings, each 21 feet in outside diameter, 18¼ inches wide. Each segment of the ring weighed about 1,000 pounds. In smaller tunnels, those segments weren't too hard to put up. There was only 4 or 5, and they'd have one ring complete, and they weren't as heavy. But because of how large the St. Clair Tunnel was and how heavy the segments were, for the very first time they used an erector arm to put those segments up. And you can see this picture of it here. And on the end of that erector arm, you can see the segment that's getting ready to go in place. In this old film clip, you can see these men. They're standing in the shield itself. Now, this isn't the St. Clair Tunnel. It's taken a few years later, but it's still a very old film clip. But you can see them working on the tunnel. Right here, you can see the hydraulic jacks moving that shield forward through the clay. And you can see the muck underneath it. And here the muck is being taken out of the shield as the shield progresses. You can see some of it is soft, but some of it is hard pieces. Here you can see these iron segments being taken into the tunnel. And you can tell from this they're pretty heavy. Here you can see them positioning some of the lower segments. Now, this seems like a pretty dangerous job as they're positioning these pieces. I'd be careful of all my fingers, make sure I count 10 at night when I left the tunnel. This illustration here of the shield showing the erector arm placing the pieces, it's a good illustration. It shows exactly how it was done. In that little segment we just looked at, it looked like the erector arm was using a chain for some of the lower pieces. It gave the workers more maneuverability to place those segments down below. Here you see the base end of the erector arm. And you can see it attached on the other end with the chain. They just placed the segment. Now, the erector arm in the St. Clair Tunnel was done manually. They didn't have the hydraulic part of the erector arm built yet or invented yet or whatever. And so it was a hard job getting that arm moved around, but still much easier than trying to place those segments by hand. Here you can see one being dropped in place on the upper level. And then they would bolt them together. One of the more difficult things to do in a tunnel like this, the St. Clair Tunnel, with a design using these cast iron segments, was the means adopted for making the joints tight against leakage. In between the radial joints was placed a packing piece of seasoned white oak, 3/16 of an inch thick. These were sawed to the exact size desired, and the bolt holes were bored a 1/4 inch larger than the bolt to allow for slight inaccuracies. After bolting in place, this wood packing piece rapidly absorbed water from the surrounding clay, and in swelling closed the joint perfectly. Join me in my next video as we watch the side from Sarnia and the side from Port Huron join together in the middle.